Okay. So here we're using prims. Let's see. Manhattan distance. So everything I think is connected to Is everything connected? No. So basically, I'm going to choose one random point and then calculate the Manhattan distance for each of the remaining points. And then I'm going to take the smallest one and then connect that and then redo that process over and over again until the points are connected. So here I'll create n, which is points.length, and then I'll create I think it's +1. 1, 2, 3, 4, 5, 1. Oh no, it's not. So then I'm gonna create a visited array with n, and then a priority queue that stores arrays called queue, and I'm gonna sort it by A0 minus B0. And then I'm going to offer the queue a new array with 0, 0, and points 0. Actually, so that'll be cost index I think it might just be cost and index. Yeah. And then let me see, while the queue is not empty, get the current point. Yeah, get the current point. Cost is going to equal cur 0, and then the index is going to equal cur 1. And then I'll also have in output equals 0 here. And if we have visited the current index, then we're going to continue. Otherwise, we're going to say output plus equals the cost. And then for int point in points, actually, for int I equals 0, I has to be less than add I plus plus. If we haven't visited that point, we're going to calculate our new cost, and that will be math.abs points I 0 minus points index 0 plus math.abs points I1 minus points index 1. And then we're going to take the Q and offer new int with the new cost and the index. And we return output. Okay. Oh wait, we need to make visited index equal true. There we go. Okay, here we're going to start at the very top left and we want to end at the very bottom right. So we're going to use breadth first search to iterate starting from the top right each adjacent cell, and then we're going to use a priority queue to store the minimum value in the cells that we've discovered. And then if we ever encounter this bottom, the bottom right's coordinates, then we'll keep a track of the largest value that we've iterated through BFS, and then return that largest value. So we'll go all the way through this, and then we'll return 16. Yeah, that's about it. So we're going to make a priority queue that stores an array called queue. Make a new priority queue. And we'll do A0 minus B0 again. Then we're going to take the queue, offer a new array with grid 0, 0, and then the coordinates. And then we will do BFS. So while the queue is empty, we're going to take the current array, and then we'll be able to initialize the val, which is cur 0, the row, which is cur 1, and the column, which is cur 2. And then we will also want a visited array or a visited grid. Let's get the length of the grid. And I believe here we can prove n is going to equal both sides, so it'll be a perfect square. Like so. And then we also want an output variable. So actually, let's see. Yeah. So any of the values are greater than 0. So if we have visited, we are going to continue. Otherwise, we'll mark visited as true. And we will make output, actually, we're going to make output equal math.max between output and the current value. And if row equals n minus 1 and column equals n minus 1, So if we're at the bottom portion or the bottom corner of the grid, the bottom right corner of the grid, then we're going to return output. Otherwise visited, we'll mark it as visited, and then and then we're going to traverse the adjacent values, which will require us to create another array, called directions, and make it equal to all the adjacent values, like 0, 1, 1, 0, 0, -1, -1, 0, like that. So then we're going to iterate through all the directions and create a new row, which will equal row plus direction 0, and a new call, which will equal column dot direction 1. And if new row is less or greater than or equal to 0, and new call is greater than or equal to 0, and new row is less than n, and new call is less than n, we're going to take the queue and offer a new array with those new values, new call, and the coordinates. And then up here, this would probably, actually no, never mind, we're good. And then after that, we're going to return the output. New Boolean right here. There we go. Beautiful. Alien Dictionary, no clue. Oh, this one's complicated. So this is Bellman Ford again, but we have to store a temporary version of the output array. So what we'll do is we'll make an output array equal to n, which is the number of nodes, and then we'll start from the source and then run Prim's algorithm onto the destination, Bellman Ford algorithm onto the destination, and then we'll check the path from source to destination and see what the minimum cost is via the array. And we'll be able to do that by running Bellman Ford and relaxing the graph. So here we're going to have int prices equals new int n plus 1, n, and then we're going to fill the prices array with with integer.max value, and then the prices for the source is going to equal 0 because we start off at the source. So then for I equals 0, I has to be less than k minus 1, I plus plus. So the reason why we do k minus 1 here is because we want to relax. It's n minus 1. The reason why we do n minus 1 here is because we want to relax n minus 1 times, because we don't want to relax for the current node that we are on. So then we can copy the array in temp prices which will equal arrays.copy of prices and n. And then we will iterate through all the flights. So for each flight in flights, we're going to take the source, which is flight 0, target, which is flight 1, and the price, which is flight 2. So if the price for the source does not equal integer.max value, and the temp price for the destination, for the target, is greater than the temp price for, or is greater than the source price plus the temp, or plus the price, then temp price target will equal price source plus price. Yeah. And then after this, prices will equal temp prices. And then we're going to return prices of destination, check if it equals integer.max value, and if it does, then we're going to return, I think, -1. Is there always an I think we just return prices at destination then. Arrays.fill. And then it's copy of, I think. Okay. Oh, wait. At most, K stops. So it'll actually be K here, I think. Oh, never mind. What am I doing wrong? Is it temp prices here? I'm pretty sure we want to make sure that the source is always from the original, right? Actually, maybe not. Yeah, okay, let's look. I don't want to spend too much time on this. Wait, that's exactly what I did. K plus 1. K stops. So K is one stop, but that's two edges, which is why we need to do K plus 1. Okay. Is that going to just change everything? It might. Yep. Okay. Well, now I know. I probably should have checked that. Oh, never mind. Yeah, okay. I knew we had to handle the exception somehow. Max value, -1, price is destination. Yep, okay. Cool. Oh my gosh. Yeah, I literally don't know how to do this, so. Let's learn. Why are you using Canvas? Why do they call it topological sort? Because we're not even sorting, are we? Let's see. I do remember this though a little bit. So we take graph, map, character. Well, actually, let me understand this freaking question first. There's a foreign language we use. Oh yeah, use the context clues of like. So the order goes by index and by index of the substring. So because R is after E, we know that R comes after E here. So that's why we can do H, H. So we know H is there. R, R. We know R is after H, but we don't know how far after. Then we have N after H as well, and F after H. So these three we don't know where they are right now, or these four. And then we see ER, so then we know that R is after E because it comes after E here. So then we know that it's each H E right now. But we just know that E is afterwards. We don't even know where E is. So ENN is here, so we know that this N comes after E and R. And then R has F after it. And then, to be honest, I don't know what these ends do. Can you explain the problem to me? I do not understand it. Oh, I see. So you just find the different characters, and that will tell you which one comes before which. T before F, R before T, so it's R, T, F, right? T before F. Oh wait, T before F, and then W before E, so it's W, T, E at the moment. And then R, T, so R before T, so it's W, E, R, T. And then E before R, which is... So does this assume that... Does this assume that every difference or every unique character will be the difference, will have a mismatch? What? Oh, interesting. Hmm. Because didn't it? Okay. Contains. Interesting. So we find each difference. If it's a prefix, then it's bad. We can't determine prefixes. But it doesn't matter which word it is. Okay. This may take forever. No, I get that. Actually, this kind of helps. So, graph. Oh my gosh, my back. Integrate. So then we go to E, integrate is 0, so we add to the Q. What's an example with multiple integers? Example multiple integers. Oh my gosh. Bruh. This is not multiple integers. Oh my gosh. No, I just graphed it wrong, probably. No, it didn't. Never mind. So, we need to create character integer integrate equals new hash map, and then we need to create character list character. I wonder if instead of a list you can do a hash map to make the adjacency list, or sorry, hash set for string word and words. For and I equals 0, it has to be less than words, word length. Map integrate output if absent. Where's the chart at I? 0. Graph output if absent. Where's that chart at I? New array list. And then for n I equals 0, I has to be less than words length times 1 plus plus. String word 1 equals words I. String word 2 equals words I plus 1. If words 1 dot length is greater than words 2 dot length, and words 1 dot starts with words 2 return. I need to check if starts with. What if they're the same? Just starts with. Oops. Hello. Okay, so if they're the same string, then it also works. Okay. And then wait. And j equals 0. J has to be less than math.min words 1.length words 2.length. J plus char c1 equals words 1.char at j. Char c2 equals words 2.char at j. If c1 does not equal c2, then we take in degree and then put c2 in degree to get c2 plus 1, and then we take graph dot get c1 dot add c2 and then break here, because we want to, once we find the difference, everything else is useless to us. Okay. Okay, that works. And then q character q equals new linked list for int or for map.entry character entry for map.key set entry set, not key set. If entry.getValue equals 0, q.offer entry.getKey. Oops. Okay, and then string builder dot equals new string builder. And then while the queue is empty, string builder append char cur equals q dot poll cur, and then for char neighbor in graph dot get cur in degree dot neighbor in degree dot get neighbor in degree dot put neighbor in degree dot get neighbor -1, and then graph dot do we need to do that? Yeah. It's like if graph dot get neighbor dot contains cur graph dot get neighbor dot remove cur. Is this no, I don't think we even need to do that. It's like we just say if in degree dot get neighbor dot get or dot contains cur, then we queue to offer neighbor, and then if string builder dot length does not equal graph dot size, return this. Otherwise, return string builder dot toString. Where is this? Right here. Words one dot length. Cannot find symbol. Word one. Jeez. Graph. No, it's in degree. Yeah. Get key is a method. This might be. Yeah, I think. Something like if this. What is it? It's not this. I thought we had to do something like that. So if the graph doesn't have these values, oh, I forgot. So this is creating. This is all about creating the array or the in degree. Wow. It's all about creating the in degree and the graph. I don't know what I'm doing wrong here. Oh. No way. Oh my gosh, that's it. Oh wait, no, that's not it. Break is a bug. Oh, do we wait? We break inside. Does it really change the answer? Why would that? Oh, I see why. Wait, no. Why would that change the answer? So what was wrong with it? Oh, okay. Alright, let's try one more time. Oh my gosh, my mouse. So we have map character integer for in degree hash map character list character graph equals new hash map for string word in words for equals 0 has to be some words for in degree dot put if absent word at char at I 0 in graph dot put if absent word at char at I new array list. Okay. For an I equals 0 has to be word side length plus 1. String word 1 equals words I. String word 2 equals words I plus 1. If word 1 dot length is greater than word 2 dot length and word 1 starts with word 2, return this. Otherwise for an j equals 0, j has to be less than math dot min word 1 dot length word 2 dot length char c1 equals word 1 dot char add j char c2 equals word 2 dot char add j. If c1 does not equal c2, if graph dot get c1 dot contains c2 does not contain graph dot get c1 dot add c2 in degree dot get c2 in degree dot put c2 in degree dot get c2 plus 1 break q character compute equals new linked list. And then for map.entry character integer entry equals map.entry set. If instead map is in degree, if in degree dot get if entry dot get value equals 0, then q.offer entry dot get key, and then string builder equals new string builder for while the queue is empty, char cur equals q.poll, string builder dot append cur if graph dot for char neighbor in graph dot get cur if no, it would be in degree dot put neighbor in degree dot get neighbor -1 if in degree dot get neighbor equals 0, then q.offer neighbor, and then return string builder dot length equals graph dot size. Then we return string builder dot toString, otherwise we return this. What? Oh my gosh. There we go. Not bad at all. Alright. I'm tired.